Hey everybody, good to see that I know a good amount of people here. It's great to see everyone out. So let's go ahead and jump in. The first slide I'm going to show is going to seem like I'm putting the cart ahead of the horse a little bit, but I wanted to jump into this because I want to set the mindset of the audience here that this is not an idea. It's not a small iterative tool that I'm talking about. This is a fundamental foundational shift in how 3D data is being prepared and optimized and consumed. And one example of that we're fortunate enough to be able to talk about as of last week is that BMW has built its 3D Mine ecosystem of its 3D collaboration infrastructure on top of our tool. So what we're going to be talking about today is Unity Asset Manager and really about democratizing 3D data and how do you get the most people the visibility of all of this 3D data that typically and historically has been obscured and very difficult to interact with, especially that BIM and CAD data that is parametric and not very friendly for visualizing at all. So I'm Cam. I am a staff solutions architect at Unity. The verticals that I typically work in are automotive, education, retail, and defense. And I am up here specifically because I have personally been in 3D data transformation for 10 to 15 years now. And at one point in my career, you could have called my title the decimation station or the retopology guy. I was that person for a while, and I know how painful that job can be. I also, on the side, teach game design and a few other things as a professor at university, so if anyone wants to talk education after the fact, please let me know. I'm very happy to be up here today, and really, I call back to one anecdote, and then I'll get on with the point of 3D data in my career, working in aerospace as one example. And I still remember having my VP come by, tap my shoulder, and say, hey, I have an executive in my office this afternoon. I need our new concept aircraft on a tablet, able to be visualized. I want to spin it around and see the rotor spinning. By this afternoon, can you get it to me? And so I then go to our one engineer that knew how to use Inovia, our PLM system, that could then pull that down and export it as an STL, so it ripped a bunch of the metadata out that I could have used. I then took that into Substance Painter or something comparable. I did an auto UV unwrap. I painted it all, made it look really nice and polished, exported that out into Unity as a URP project, built it all to a tablet, and it was looking amazing. I hand it to my VP, and he says, hey, this is great, but the tail is from the version yesterday. I need the new one. And so the issue then is it's not a small change. I have to go back to the engineer who has to figure out who didn't push that data to CATIA at the right time in our Inovia PLM and figure out who effectively dropped the ball and how now I'm going to spend a whole second day on iterating on that whole process because that UV unwrapping, the painting, it all has to happen again from scratch. The idea is that that is going to be eliminated with this tool. So the agenda for what we're going to talk about are what are the challenges that we were seeing in the industry that prompted us to create this? What is Unity Asset Manager? So that's kind of a what is it, what are the effective offerings, what's the value proposition of this, why would you use it? And then we're going to look at two separate demos. So the main reason that we ended up working on this tool is that we were seeing time and time again in conversations that companies are wasting a lot of time and money, not just finding assets, but recreating assets or duplicating the creation of these assets. So you'd have a marketing team paying an agency externally to make the same model that the engineering team had done internally over the course of 2 weeks, a few months back, and all of a sudden you've just wasted a lot of time. It's also very difficult to track changes and understand exactly where your 3D assets are at all times in the pipeline. And I always love to show this slide. We have dozens of quotes, but my favorite by far is this bottom one. I can see every step of my pizza delivery, but I have no clue where our 3D assets are. And I feel like we all can resonate with that to some degree. So what are teams doing today? Typically, we see teams building short-sighted storage silos. What that means is we work with, let's say, a company of 1,000 people. They have 10 different teams within that company that are each using 3D data in a different way, and each of them have built a way for them to consume data that worked for them. And what happens is that then you have team A and team D that are both looking at the same asset, but there's a difference in them, and nobody knows why. And we're trying to figure out how that would happen. So we're trying to consolidate that, eliminate these silos. Secondly, we've seen teams piece together solutions with brittle scripts so that they can typically build something that works for now as a team of 2, 3, 4, but as that scales up and as it balloons out, things get inefficient and things start to not quite work anymore. And that's where you really need something that's going to grow and be robust. The last piece here is leveraging a traditional 2D DAM solution. So let's say GitHub. GitHub has a great LFS, large file system integration for it, but it definitely eventually becomes a kind of duct-taped solution onto what was originally intended to be a code base pushing and pulling system. It wasn't intended originally for large 3D data and scenes and projects. And that's why we built this custom for that use case. So Unity Asset Manager is fundamentally a cloud-based digital asset management solution, and it is where you can upload, manage, transform, version, comment, download, and leverage your assets across the board. I also want to point out that there's a bit of a misnomer in the name Unity Asset Manager because it does not require that you're using Unity in your pipeline at all. It truly is agnostic. It does not care where the data is coming from. It doesn't care where it's going to. And we actually have tools that we'll talk about in a bit here in the SDK that comes with this that can enable you to build your own integrations into quite literally anything that you're looking to do. So any type of front-end CAD or BIM system that you really want to have integrated into your pipeline, you can have this integration and build it through the SDK, and any output that you want to have to visualize that, whether it be a game engine or otherwise, that can be built as well. The product features are fundamentally asset discovery, asset management, asset transformation, which perhaps I'm the most excited about given that a lot of what we're looking at here today is built on top of Pixie's SDK. Can I see a show of hands? How many people know what Pixie's is in the room? Okay, so I'll cover it for 20 seconds and then we'll keep moving forward. So Pixie's is a tool that Unity has that is built to ingest significant amounts of data that is typically not friendly with a polygonal mesh workflow. So what that means is that it is meant to ingest parametric BIM, CAD, point cloud data, even just super gnarly polygons, allow you to optimize that quickly and then spit out those nice optimized polygons on the other side of it. So by building this tool on top of that, we're able to infuse those transformations into your process in Asset Manager without having to open up Pixie's on the back end yourself if you don't want to. The last piece here is asset storage and security. One important call out here that I'll make beyond the fact that we have role-based access controls and identity access management systems that support SSO and many other things is that the safety of your data and the ability to remove or keep those important pieces like metadata, PMI data, and other are all built into this system in a way that if I want my engineering team to see the metadata that lives within my CATIA file, for example, and I keep using that as an example since that's the pipeline I come from, but if I want to pull that metadata through, then I can preserve that and allow the engineers to access it. But if I don't want my marketing team to see that because they don't have any business knowing what the metadata is or the dimensions of certain pieces of my model and potentially leaking intellectual property to external agencies that are commissioned to work on renders for us, then I can also remove that intentionally, which is an inherent security feature built into it. So industry workflows. This is what people typically think of when they think of Unity. So you have Unity Editor, where you're going to use C# and pull in your 3D models, light it, do post-processing, and effectively build your interactive environment. And then you have the runtime. So that's where you'll push out your executable, your APK, and that's where you're going to actually be running on a device, whether that be a VR headset, mobile, web, what have you. What we're talking about today is a bigger look at the ecosystem. So looking beyond just the editor and runtime, we have data transformation, which is fundamentally Pixie's as our core technology. We have asset management, which is what we're here talking about today. And then we have version control, which is more about versioning large-scale projects across teams. You'll notice that there's also a check mark under all of these, except for one area, which we can discuss. But effectively, all of these are available on public Unity Cloud, on virtual private cloud, in like an AWS tenant or an Azure tenant, or on-prem. The only one that is not offered on-prem today is Unity Asset Manager, but that's not to say that it can't. So if that's a requirement of your organization, let us know. We'll have a conversation with you, and we would love to better qualify that desire and demand, and we can talk about it from there. So again, we're going to dive farther into Asset Manager from here. This is the typical workflow that you're going to see inside of a real-time 3D workflow. So the top two nodes that we have are really if you're working with polygonal mesh or polygons. It's a pretty friendly workflow. It's tried and true. It works very well in game engines. So that would be if you're coming from a 3DCC tool, let's say Maya, Max, Blender, C4D even, or the asset store to get game-ready assets and pull those into the editor. You can, on the other hand, look at a bit more difficult process, I guess I'd say, objectively, of importing parametric data. And that is typically what you're talking about when you're talking CAD or BIM, also importing point cloud data, importing even nasty polygonal mesh from things like a PLM database. All of those are typically needing to go through a process before going into the editor. And that process here can be kind of an either or and situation, if that makes sense, and that you can go straight into Pixies, and you can use something like Pixies Studio or Pixies SDK to optimize those models. Then you could push them out to Asset Manager where you can manage those. Or you can go directly into Asset Manager if you're needing more of a high-level look at the transformation workflow, and you can leverage the pieces of Pixies the Asset Manager has built into it. From there, you can then go into the editor, where from the editor you can leverage additional services like version control or build automation, and then eventually get to distributing your app across different pieces of hardware. So that would be your, again, XR devices, mobile, web, et cetera. So what is the core value proposition here? The first is that this is a flexible and extensible tool. So it's API first, open, digital asset management. The second, and this is one I'm very excited to get to show a demo to you on, is our Unity editor integration. So this is, again, without repeating the point too much, we allow a full use of an SDK that comes with Asset Manager so that you can create an integration with anything. We have created the integration with Unity. So we are going to maintain that moving forward and ensure that it's meeting all of your needs. And this integration you can get into the editor and leverage today and start to see your assets that exist within Unity Asset Manager. From here, you can push, pull, upload, version, et cetera, all of your assets directly from the editor, so you don't even need to leave that. We also have the multi-format support, so the fact that this is all built with Pixies as a backbone to it means that we support those same files that Pixies supports, which is over 70 different file formats, bridging across all of the CAD, BIM, point cloud, et cetera. So to dive into flexible and extensible, and just to make sure that we keep this moving forward, because I'm looking at the clock here, we do have full SSO support, as well as role-based access controls. We also have our virtual private cloud solution and deployment of this, which is AWS and Azure, as well as webhooks and Python APIs to leverage. For our Unity editor integration, we have prefabs, materials, textures, shaders, et cetera. All of these things that you would think of that need to be supported inside of a game engine are understood and contextualized by Asset Manager because it is built for this workflow. The other thing to mention here is that it doesn't just stop at a prefab level. You can also commit full scenes if you need to. It even understands what a project is or cross dependencies of assets in your Asset Manager. This is perhaps one of the coolest slides, so I want to take an extra minute on this one. So this, to me, as a 3D artist and a technical artist, is a fundamentally new technology that we are leveraging that you can use and actually go by our booth, please, after this and check it out firsthand. We have this running live. And what this is a runtime integration. And that means that in a runtime, running on an application, a headset, web, what have you, you can go in here and actually access all of the assets that you're intended to access through your role-based permissions. And you can pull those assets down into your runtime environment. So if any of you have used GLT Fast and things of that nature, it's not dissimilar from that, from a technology perspective on how you can leverage it here at the runtime. We even have a template project that we have built that we're allowing access to for anyone to get into that you can use as a template to build your own runtime viewer or collaborative interactive design review tool. And effectively what you can do here is leverage some of the built-in pieces of the template like multiplayer, like the Vivox voice chat and a few others. And what we're seeing here in this video on the right is not just a singular asset brought in for a multiplayer design review session. We're seeing multiple assets brought in, and each of these assets that we're looking at here running in a runtime, they can be on a tablet and on web again, each of these are over 60 million triangles and over 10,000 parts. So we're now seeing 4 of them that we're looking at in real time. I had a colleague that I'm not joking at all when I say he used his smart fridge to test some of the functionality of the URL browser and was spinning around massive assets through this technology. So what we're looking at here is we're going to zoom in through the window and see a bit of how the tech is working on the back end, which is you can see some of the LODs loading in. So as we pause the camera, the fidelity increases. You can think of this technology almost as a combination of geospatial 3D tile mapping and hierarchical LODs, if that makes sense. So there's a bit of a combination there of the different technologies. And effectively, that's why we're able to show such massive, dense models, is because they're all fragmented into minuscule pieces that we can up-res and down-res as is appropriate to the viewer in the camera frustum. We also have from within Asset Manager the Optimize and Convert node. So for those of you that have ever used Pixies, this is one of the coolest tools in that you can have a user that doesn't need to understand topology at all, who can grab a file that could be a part file, an assembly file, what have you, bring it into Asset Manager, and then run an Optimize and Convert on that. And by checking a few of these on, like mesh cleaning, merge optimization, polygon target, you can specify a new poly count that you want that asset to hit. You can run this operation and specify the output files that you'd like, and it goes. It just does it for you, and then that file outputs on the other side. And now that's stored with that asset in Asset Manager. Another piece of this tool is that you can use automation and pipelines. This is one that is moving towards general access. I can't give a definitive date on that, but we are making very good progress on it. And this is a tool where you can create recipes and a subset of steps that you have found work very well for specific types of assets, and then run those on repeat as those assets come through. What that looks like from a UI UX perspective is just another tab right there within the Unity Cloud dashboard. Underneath Asset Manager, where you can create from a node-based system these steps and these recipes that you'd like to repeat. One of the coolest things that I think to point out on this slide is that you'll notice that the second node here is actually a run custom script node. So if you've been using Pixies or you want to use Pixies for more in the weeds transformations, you can actually do that and then leverage those custom scripts as a node within the system and automate that process for users who might not need or want that level of sophistication in Pixies. So we now have 2 demos, and I timed that great, so that is awesome. We'll go ahead and dive into the first one. So this first demo, we're going to look at integrations. So we'll look at both the Unity integration and the Blender, and we're going to be looking at this radial engine asset that I have here. So this is an FBX export that I exported using the Optimize and Convert feature in Asset Manager. The integrations are accessible through Asset Manager right here in the integrations panel. So we can see right there that you have access to Unity and to Blender. This is looking at that asset that I have moved, repositioned, and scaled in the scene. So we can see our radial engine right here live, and we can see the Asset Manager window over on the right. From here, you can also get into versions and versioning, as well as look at source files or not be able to if we didn't want that. Inside of Blender, we can now make a quick visual change. So let's just change the rotor from green to red so that we have something very obvious that we can see has changed. And now I'm going to go up to the Unity Cloud panel at the top. This is, again, just a plugin. I'm going to upload that FBX to Asset Manager. From here, I can pick the organization, the project, if I want to create a whole new asset or update the version to a new version of an existing asset. So we're going to add a new version. And then you can also add in asset descriptions, tags, et cetera, that we're not going to do for the sake of this demonstration. So I'm gonna hit OK, and it's going to pull up the Asset Manager window in the back end, just so that I can see that the change has been pushed to Asset Manager. Now that I've verified that the change has happened here, I can go back into Unity, take another look at the project that I'm working in that asset with, and I can see that there's now an icon change that says, hey, this asset is out of date. I need you to do something about this. So I can now go into my versions tab and I can step forward or backwards if I want across versions, or I can just go in the details panel and update to latest, or I could even update all. From here, it's gonna say, hey, this is the asset that's going to change. Do you wanna do this? And I'm gonna say, yes, go for it. And now we're gonna see the visual change reflected, not just in the Asset Manager window on the right, and not just in the prefab on the bottom, but anywhere that that prefab has been used in any of my scenes as well. So it propagates across the entire project. Our second demo that we're gonna look at is more staying just within the Asset Manager window, and that is uploading an asset. So I want to first point out this is not smoke and mirrors. This is a true parametric asset. You can see here there are 0 triangles. When I turn off BREP visualization and pixies, it disappears entirely. So what I'm going to do is take that asset, come up here and add an individual asset from Asset Manager. If this existed within a project that I was managing in Unity version control, I could actually pull it in from the repo here in UVC, or I can just upload from my local repository. So I'm gonna upload from my local drive, grab that part file, and go ahead and push it. And now that that has been pushed, we can start to see a few things happening in the bottom right over here. So when I expand that, we can see that we have the 3D preview, the metadata extraction, and generating thumbnails that are all happening for me. Again, I didn't ask for any of these. They're automatically in there. I don't have to know anything about 3D data for these to just start happening. So the upload has already completed. And now we're going to move through these different pieces of the puzzle without us having to manually do any of it. What we see coming out on the other side is that the 3D preview has now completed, which means that it has taken that part file, it has tessellated it, optimized it, and exported it as a previewable web GLB. So I can now see that here. Now before we look at what just came out of that process, let's run an optimize and convert. So we're going to go ahead and turn on mesh cleaning and the merge optimization as well as a poly target. And we're going to specify a poly target of, let's say, 25% and name this that we want it to be a low poly asset. We can then specify, let's say we want to do a USDZ file or something comparable. Now we can hit run. And while that's running in the background and doing all of that optimization and conversion for us, we can take a look at what came out of the initial upload process, which is this GLB file that now my design team can get in and immediately spin around and see what they do, don't like, and how it's changed from previous versions and iterations. We can also get in and see that there's metadata and also PMI data that's been preserved on the right-hand side over here. So the beauty is that without anyone having to understand how to move from parametric to polygons, we can now get really nice, crisp feedback from the leads. It also creates these automated thumbnails so that we'll render these out in a front, side, isometric, and top view. And it does preserve those files because we've asked it to. So it'll show us the preview files as well as the source. We can also see the versioning and step forwards or back from a versioning scene here and go into comments. So if I see this and I say, hey, I don't love the blue, change that to a green and get back to me, please, with a version 2. I can make that change and I can send it off and have the initial developer make that for me. The last thing that I want to point out here is if I hit edit and I go back to the output of our optimize and convert feature, I'm going to see here that we have taken a 10.5 megabyte file down to 175 kilobytes. And we have done that again with the user not needing to understand topology or geometry or the difference between parametric and polygon. So we have a few demos that we are running at our booth. We are right out there on the show floor and having a great time. And it will be looking at our web GPU demo. So the bottom left, I kid you not, is web GPU running in real time. So that is a great scene that I would encourage you to come check out. We are also running an Apple Vision Pro demonstration, as well as a demonstration of this asset manager, as well as the 3D data streaming and that runtime implementation of our template project. If you have any feedback on this session, I would very much appreciate it. It always helps us out a lot. So please scan that if you feel so inclined. And other than that, I think we're going to go to Q&A, and I appreciate y'all's time and listening.
Yeah, if anyone has a brief question, 1 to 2 sentences max. Great. I saw your hand go up first.
Do you see any, okay, do you guys see any differences when you take, like, I noticed the helmet was coming from SolidWorks, and do you see any difference coming from, like, SolidWorks or Revit or Max or Blender or whatever? Do you see the different, like, I guess, fidelity when coming from those different applications to Unity?
So typically, I would say that the fidelity output, I expect no variance between those file formats of input. I would expect if I have, let's say, a factory floor that is a Navisworks file versus a small engine that is an assembly file, that what I would likely want to do is leverage that automation system and create nodes that effectively say, hey, if you're bigger than this scale, cull that out entirely or decimate at this level. If you're meeting these metadata requirements, I want to preserve this piece of that. And you'd probably find that you would modify it and have a different process for each type of file, but not necessarily that there would be any difference in the expected quality output. And a lot of that, I have to give a lot of props to the Pixies team. That was a fantastic acquisition many years ago by Unity, and we have been evolving that technology every year in a big way, and it's built to really make it so that all of those files come through, and what you see on the other side is what you expect to see.
I have other questions, but we can talk about it.
Sure, yeah, I would love that.
All right.
Thank you. I'm just curious to know what happens if I interject an intermediary software such as Substance Painter into this workflow? How is that affected?
Yeah, great call out. So we do support material and texture preview generation inside of Asset Manager, which can happen when you initially upload the file. What will typically happen is that you will, let's just say you push up an assembly file, you've converted it to an FBX, you take the FBX into Substance Painter, where you then generate new UVs or whatnot. Let's say you auto UV unwrap it. So from Substance Painter, you could then push that file back up and have that override to a new version of the 3D asset, as well as have the textures pushed out. And let's say you're doing a Unity HDRP project, so you've done a Unity HDRP template. In that case, you would have your color map, your mask map, and 1 or 2 others that would have pushed out as well. You could push those up in the Asset Manager and create a dependency between those textures and the material and the 3D asset, so they would all stick together across your projects.
Kind of like a prefab.
Yeah, exactly. Works a lot like a prefab.
We have time for one more very brief question, if anyone has one. All right.
So did I understand you correctly that you could pull assets in a lazy loading fashion directly from the Asset Manager from your application, or do you need to have a second step there?
So typically, when you upload to Asset Manager, you want to allow, there is a pre-production time or a pre-processing time rather that happens when you first upload. So typically you'll upload, let's say it's a very large Navisworks file like our factory floor, let's just say. It will need time to process and to break down into those 3D tile mapped, 3D data streaming compatible file formats, which will take time. So I don't want to give any false illusion there. But after the pre-processing is done, it's virtually instantaneous, in which you can see that inside of an application at runtime and have that data streaming down. But you do have to get through the pre-processing phase to make sure it's done right.